All right, so this is Math 2. We're on lesson 322. We're going to connect the slope ratios to specific angles. So if you recall in lesson 321, we recognized that there were some patterns in what was happening with the degree of the angle depending on the slope triangle. And we started with the slope triangle of 1/5, and we had an angle of 11 degrees. And then we moved on to a couple of other things, but that was where we started. So the first thing we're going to do is we're talking in lesson 321, we've started trigonometry, the studies of measures of triangles. As you continue to investigate right triangles today, we're going to discuss these three questions. What do we know about this triangle? How does that relate to other triangles? And that's the key, notice it's bolded. And which part is delta x and which part is delta y? All right, so here's my angle. Notice that it is 11 degrees like we were studying yesterday. And so if we remember from yesterday, we had that really long line, and we done the one slope triangle, and it was 1 and 5, and then we knew this angle was 11 degrees. So something like that. Okay, so what is happening here? Since a ratio of 1/5 means that there is an angle of about 11 degrees, what can we deal with here? Remember, everything's being rounded to the nearest whole degree. It is not exactly 11, it is a decimal, but we're rounding to the nearest whole degree. So y and 20. So if the bottom is 20, what must this be? Remember that whatever it is, the change in, so delta x and delta y, delta x and delta y, which one goes on top? So I should probably write it in a better order so that it's, so delta y on top and delta x on the bottom. And so delta y in this one we do not know, and delta x is 20. And so I have y over 20, delta y over delta x, change in y over change in x. I'm going to write that over here. That's really, really important. So I'm going to go ahead and write that down. And so what do I know? Well, I know that these have to be the same, right? Because if that angle is 11, then the new triangle has to be similar to it, because we've got all sorts of things going on here that have to be true. So if that angle is similar, what do I need to do? And so I need to be able to figure out what y is, but it needs to simplify to 1/5. So thoughts? Just thinking. Granted, you can't share your thoughts with me right now, which is too bad. We can set up a proportion if we would like and try to solve it. We can use reasoning to help us solve this. Like, oh, I have to multiply 5 by 4 to get 20, so y must be. If we went ahead and solved this, we'd have 20 equals 5y, which leads to y equals 4, which is also, since I times 5 by 4 to get 20, 1 times 4 is 1. So I believe y is 4. And again, I'm using that information from yesterday, this 1/5 from class, not really yesterday, from class to help me remember that. Okay, so again, looking at this, we've got 11 degrees right here. We got 22. I don't know if you remember what happened with 22. We've got a 45-degree angle right here. We'll come back to that one. We've got 3/15, and our last one, I think that's the bottom of my space, so we'll just move that up a little bit here. We have 20/50. So let's see what we can do, because in these last three we're looking for angles, and the front two they've given us an angle. So B is exactly like the one we just did, except for what is missing. So delta y and delta x. So delta y is, kind of focus in on the equations. Delta y is 100, delta x is what I don't know, and my angle is 11. So since it's 11, I've got 1/5 as my ratio. And so delta y goes on top, and delta x goes on the bottom. I multiplied 1 by 100 to get 100, so the denominator needs to be what? Go ahead and answer that question. I hope I agree with you when I say 500 down here, because And now I can also set them equal. Cross multiply x equals 5 times 100, or 500. Okay, so pretty straightforward. Now, what do we remember about 22, which is double? The angles have doubled. Do you remember what we talked about in class? What happens here? So what happens is we end up with 2/5. We don't double the whole thing, but if you double a fraction, like when you double, I have 1/3, and then I have 2/3 when I double a fraction. So when you double a fraction, you only change the numerator, not the denominator. So like if I have a pizza cut into 5 pieces, and I take 1 and I want double, I would take 2, right? 2 slices of pizza, or 2/5. Okay, just something to think about. All right, so 22, we double this too. Double, double, double. It's just a weird, sometimes we think double should be 2/10. But it's 2/10. It's the same fraction, so that's not really doubling. Okay, something to keep in mind. And so, what is delta x and what is delta y? Go ahead and write that down if you feel like you know. Delta x is 25, delta y is y. So I have y over 25. And again, thinking, I times 5 by 5 to get 25. So I'm going to times 2 by 5 and get y is 10. Or I can cross multiply them. 2 times 25 equals 5y. 2 times 25 is 50. When I divide by 5, I get 10. So either way, y is 10. Okay, now, this is 45. What does that mean? So on the closure assignment for the Chapter 2 test, there were some problems where we talked about angles and the side relationships and what had to happen. Since all the angles add up to 180 in this triangle, right? This is 90. These two angles have to add up to 90. This is 45. That angle is 45. Which means the slope ratio will be 1, which is the last question we did in class. The slope ratio will be 1. And so we have a slope ratio of 1 over 1. And so A has to be 13. And also because the angles are the same, the sides opposite them have to be the same. It must be isosceles to have 45-degree angles in a right triangle. Okay, A is 13. So then jumping to D, these two are the same. What do you know about theta? I'm going to leave that one as a question. I'm not going to tell you the answer. So I'm going to leave it as a question. See what you know. All right, with all that said, we're going to jump down to these. So E and F. All right, so what is delta x and what is delta y? Delta y is 20. Delta x is 50. When I set up my ratio of 20 over 50, which simplifies to 2/5. And so 2/5 is this one. What is theta? Or in other words, the angle. I'm going to leave you to think about that. For this triangle, delta y is 3 and delta x is 15. So again, delta y, which part is delta x and which part is delta y? Delta x is the horizontal movement, sideways. Delta y is the vertical movement, up and down. Delta x, horizontal. Delta y, vertical. As long as the angle is in the bottom right, bottom left. That is true for that. If the angle is not in the bottom left, we'll talk about that in just a minute. Okay, so back we go to this one. 3 over 5. So my ratio is then 3 over 15, which is equal to 1 over 5. So what is theta? And again, go ahead and answer that. So we have this one that I left out and didn't tell you. I'm not telling you. You should have answered that already. And then this one is 22 degrees because it's 2/5. And this one is 11 degrees because it's 1/5. And this one, my ratio of sides is 4/4 or 1/1. So again, I'm not telling you. Figure it out. Okay, it's 45 degrees. I hope you figured that one out easily though, especially since it followed right after that one. Okay. So there we go. That's page 1. Now, there's nothing in the sidebar, so I'll just use that as I need it. Use the triangle to answer the following questions. Use what you know about the slope ratio of 11 degrees to determine the slope ratio of 79 degrees. So, 11 degrees, the slope ratio is 1/5. Slope ratio 1/5. So that means basically we're going to solve for B to help us figure out what was going on with 79. We'll get back to 79 in just a minute. Okay, so that means that delta y first, excuse me, delta y over delta x. So delta y is 7, delta x is B. So I multiply 1 by 7 to get 7, so B must be 35. Okay? So that 1/5 can equal 7 over B. Okay? So that means B equals 35. Just cross multiplying. So if I know that, what about the slope ratio for 79? So this is what I was just alluding to. Sorry about the blurriness of this camera. That's what I was just alluding to about orientation with the whole horizontal and vertical right here. If the angle's in the bottom left. Now our angle 79 is not in the bottom left. I can reorient my triangle though. I can flip it and turn it and do all sorts of stuff. I can make my new triangle go like this, sticking 11 up here. And 79 would now be down here. This side will still be 7 because I just moved it. And this side would be 35. And again, I'm sorry about the blurriness. Okay. The other thing I can do, which is a lot easier, is turn my paper, right? 79 is down here. Now it's not in the left. So maybe it doesn't have to be in the left, it has to be in the bottom. Now we have horizontal and vertical. Horizontal, vertical, horizontal, vertical. Okay, so the slope ratio will not be 1/5. The horizontal movement now, or maybe instead of horizontal, I should say adjacent to the angle, right? The one that's touching the angle I'm talking about, that line that's not slanted, that is what I'm talking about. That's delta x, which is weird. Okay, so now delta x is 7. And delta y is 35, or B. So if you look at it this way, with I have flipped and turned. I have flipped, which I can't do on my paper, but I flipped and turned, and I have this triangle. If you want to think about it, what I did is, see how I flipped and turned, and I don't know if you can really see through my paper. And I was able to see through the paper, redraw it. This is 79, this is 11, this is 35, and this is 7. So 7 over 35. That makes sense. Delta y is 35 now. Delta x is 7. Okay, so 35 over 7, which is equal to 5 over 1. Okay, follow me there? So what is the relationship of 11 and 79? 11 degrees plus 79 degrees is 90 degrees, which means they are complementary angles. Complementary angles. Okay, they add up to 90. They're complementary angles. What is the relationship of their slope ratios? They are reciprocal. Okay, very important because the sides aren't going to change if these two see it, and how they complementary angles will always be in a right triangle. It's a secret. Complementary angles are always in right triangles. Complementary angles are in right triangles. Okay. Questions? All right, moving on. For what other angles can you determine the slope ratio based on the work we just did? Find the value of the missing angle. All right. So this is 68. This angle has to add up to 90. So 90 minus 68 equals 22 degrees. Oh, hey, I know that one. Since I know the slope ratio for 22 degrees, what other angle do I know the slope ratio for? Use tracing paper if you have some. Which, I don't really. But, yeah, I really don't have any tracing paper. So, but I know that this is supposed to be 2/5. And since I just said a minute ago that they're reciprocals, this must be 5/2 if that's true. A little hesitant there. But then I would have delta y is 30. Delta x is x. And so 5/2 equals 30/x times by 6. So x is 12. Let's cross multiply and be sure. 5x equals 60. X equals 12. Okay. Think about it. If it had been this way, now this is delta y, and that's delta x. And so I would have 2/5 equals x over 30. Notice that these two are the same proportion. All we've done is flip both fractions over. Same proportion. Same proportion. Okay? Use the information to determine the value. Okay. So because I did all of my work up here. So all they were asking for is the 5/2, and then I went ahead and did all the work. Okay, write a conjecture about the ratios of the relationship of slope ratios for complementary angles. So remember, complementary means adds up to 90. So for sums of 90. If one angle of a right triangle has a slope ratio of a/b, then the other angle in the right triangle has the slope ratio of blank. Take a minute, write that down, decide what you think goes in the blank. I believe it is b/a. I use my blank a little weird, so not what's funny. I don't like that one either. Goodbye, blank. b/a. There. I should have made a box instead of a book, but that's all right. All right, there you go. I hope you enjoyed this. I will talk to you all soon.